Welcome to ChemTarget. This is Dr. K.R. Bandi. Let us solve this problem. In the reaction, carbon is reacting with carbon dioxide, producing 2 moles of carbon monoxide. The equilibrium pressure is 12 atm. So they are giving us the value, the total pressure at equilibrium. It is as 12 atm. If 50% of CO2 reacts, the value of Kp for the reaction is. They are telling us that 50% of CO2 is consumed in this reaction. First of all, let us write the equation. Carbon is reacting with carbon dioxide, producing 2 moles of carbon monoxide. So carbon is given as a solid state and carbon dioxide is in gaseous state, CO is in gaseous state. So at time t is equal to 0, I am treating the concentration of CO2 as 1 mole. I am not considering, or I am not taking the solid component. Why? Because its concentration is going to be 1 in equilibrium. So that's why I am not considering this. So the concentration of CO2 or the number of moles participating in the reaction at time t is equal to 0 is 1. At time t is equal to equilibrium condition T, so its concentration is reduced by some x. If it is reducing by some x, the concentration of carbon monoxide is going to be 2x. But from the given data, we come to know that 50% of CO2 is consumed, which means that 50% of CO2 is consumed, which means that x is equals to 0.5. Then the number of moles of CO2 is equal to 0.5 and the number of moles of carbon monoxide is 2 into 0.5, that is equals to 1. So these are the number of moles, and if you calculate the mole fraction, mole fraction is equals to number of moles divided by total number of moles, that is equals to 1.5, and here it is 1 by 1.5, 1.5 and here it is 1.5. So I am taking this directly into the formula, and let us write the formula for Kp, that is equals to x CO square, mole fraction of carbon monoxide square, divided by x CO2 into P total power delta n, where delta n is equals to 1. So substitute those values in this. XCO, carbon monoxide, is 1 by 1.5 square divided by CO2 is 0.5 by 1.5. So if you simplify this one, 1 by 1.5 into 1.5 into 1.5 divided by 0.5. This is on simplification, where we forgot to write the P total. It is equals to 12 atm, which is given at this. So 12. So finally we are getting the value. On simplification we are going to get 16. So Kp of this reaction is 16, which is equals to option number 2. Thank you.